Bismillahirrahmanirrahim. Assalamu alaikum students. My name is Ishan Akbar. In this video lecture, we are going to discuss the canal design concepts. What are the steps which are basically needed for the design of a canal? So, basically, for this, I have taken as a first instance the non-alluvial channels or non-alluvial canals. For the design of non-alluvial canals or channels, I will let you know the basic concepts, background scenario, and the proper designing steps for the design of a non-alluvial channel or a non-alluvial canal. So basically, what is a non-alluvial? Here, the word alluvial means something. So whenever we see the word alluvial, so basically we mean that the channel is non-erodible, means material is not transferred. Whenever you see the alluvial, it means transfer of soil with flowing water. Water was flowing through a channel and there was a phenomenon of erosion. With that phenomena, soil was eroded from the bed of the channel and banks of the channel, and that material was transported with the flow towards downstream side of the channel. But in non-alluvial channels, this does not happen. Alluvial soil is not available in case of non-alluvial channels or canals. So basically, we can say that soil is not transferred with flowing water from upstream side to downstream side or from one section to another section. So basically, this is the background of non-alluvial channels. So what are characteristics of non-alluvial channel? The first characteristic or first property of a non-alluvial channel is that they are stable because material cannot be eroded and transferred, so they are stable channels. The second characteristics is they are made of natural soils like cobbles, rocks, etc. Means you can say that they are made of strong clays and strong materials which cannot be eroded with the force of or with the velocity of water, and they can be designed with the maximum permissible velocity. So here the velocity is maximum. So permission for velocity is maximum. We can keep it as till 2.5 or 2.6 meter per seconds. So what is maximum velocity or maximum permissible velocity? It is the velocity at which there is no scoring. If there is no scoring at a velocity and it is the maximum value, that if we increase a minute value beyond this velocity, scoring will start. So that is the maximum velocity at which the scoring does not start. So there are three characteristics of non-alluvial channel. The first one is that they are stable channels. So there is no transport of material or no erosion of material from one section to another. They are made of natural soils, means there is no need of lining. They are made of cobbles, mean their structure is made of cobble bed and banks, or rocks or strong clays, and they are designed for maximum permissible velocity. It means that there will be no silting problem in these channels. And next is the criteria to set the side slope of the channel. First thing here is this shape. The shape of the non-alluvial channel is generally trapezoidal. So we take mostly the shape of channel as trapezoidal, but we can also adopt the shape of the channel as rectangular. But as they are natural sources of water or natural terrains or natural channels which are used to drag water or take water from one point to another from upstream to low stream, so they generally take the trapezoidal shape, which is a natural shape. So if your channel is in clay soil, the channel is non-alluvial and the bed material and bank material is a strong clay, so we will keep the side slope as 1:1, mean horizontal versus vertical. In cutting, and if the material is being cut from that side, so side slopes of the channel will be maintained as 1:1, mean 1 meter in horizontal. If you are moving 1 meter horizontally, then you will move 1 meter in vertical direction. And if you are designing that channel in filling, then you will move 1.5 meter in horizontal direction and 1 meter in vertical direction. And for grid channels, the side slope will be 0.5 ratio 1. For soft rock channels, the side slope will be 0.25 ratio 1. And for hard rock channels, there will be a steep slope of 0.125 ratio 1. Mean you will move vertically more. This ratio shows that the vertical movement is 1 times, and 100%, then the horizontal movement will be just 12.5%. So as your materials becomes harder, then the side slope becomes sharper, mean you are obtaining the side slope, steep side slope. So for designing the non-alluvial channels, we use two equations. The first one is Chezy's equation. So this is very simple equation. Here we can see that V is equal to C and square root into R times S. Here, what are these factors? V is the velocity of flow through the channel, and C is the Chezy's coefficient. This Chezy's coefficient can be directly given in the question, or you can use various formulae to calculate. You can use this Bayesian's formula to calculate the Chezy coefficient. It is 87 over 1 plus k by r square root. Here the k is the rugosity coefficient. This is known as Cutter's rugosity coefficient. You can use this Cutter's rugosity coefficient to determine the value of C, and R is the hydraulic radius. You can use the word formula for Cutter's. This is also for the determination of C. So for C, we use two formulae. First one is Bayesian's formula, and next one is improved formula or modified formula, that is Cutter's formula. In this, we will need a value of n. This is Manning's roughness coefficient, the bed slope of the channel, and hydraulic radius. This one. So you will need three things in case of Cutter's formula, and only we need two things in case of Bayesian's formula. Whichever data is given, you will use the respective formula in your calculations. So next, R is the hydraulic radius. And as we are elaborating this formula, so V is the velocity, C is the Chezy's coefficient, which is determined by two methods. First one is Bayesian's method, and next one is Cutter's method. And R is the hydraulic radius. This is equal to area of flow over wetted perimeter. This formula will vary for different cross sections or different shapes of the channels. And S is the bed or longitudinal slope of the channel. We normally see two slopes given in a question. First, one of the slopes is bed slope or longitudinal slope along the length of the channel, and the other slope, this is the normally bed. The slope is normally given for the bed, not for the sides. And the other slope is side slope. There is no connection between side slope and the bed slope. These both are different things. So you have to understand this, because here S is known as the bed slope. So you can simply say that this bed slope will be like this one. This can be seen in longitudinal way. Let us suppose we have this horizontal line. So this slope will be, you can say this slope, mean vertical over horizontal. What is movement of vertical with respect to horizontal distance? This is V by H, and side slope is given by H by V. So simply we can say that bed slope is written as vertical movement along the length of the channel divided by the horizontal movement. So the second equation is Manning's equation, which is used. This is the most famous equation for open channel hydraulics. So normally we use this equation for the design of non-alluvial channels. For first instance, we also determine the velocity with this equation. Here we can see four things in this formula: V, N, R, and S. We are familiar with R and S and V. V is the velocity of flow. N is the Manning's roughness coefficient, because this is Manning's equation. So same like C, this N is in replacement of C, 1 by N. Simply, if you are going in SI units, then this will be the formula. If you are going in FPS units, the formula will be 1.49 over N, R raised to power 2 by 3, and S raised to power 1 by 2. Simply, there will be a factor of 1.49 in case of FPS units, mean your fits are length units, pound is the mass unit, and second is the time unit. But if you are going in system international units, then the formula for Manning's velocity or Manning's equation will be this one. So N is the Manning's roughness coefficient. This can be determined from table, or it may be given in your question like C or K. And R is the hydraulic radius, same as in the previous case. Same S is the bed or longitudinal slope of the channel, which is determined as vertical distance along the length of the channel to the horizontal distance between two sections. So we have two design procedures for non-alluvial channel design. First procedure is followed by the five given values. If the value of discharge, mean Q, velocity of flow, Manning's roughness coefficient, bed slope, and side slope. The side slope is denoted by M, while the bed slope is denoted by S. So if you are given with the five values of Q, velocity, n, Manning's roughness coefficient. This can be shown by small n. You can denote this by small n as well. And S is the bed slope. This is sometimes known as S naught. And M is the, you can denote this sometimes by Z. And this is known as the side slope of the channel. If we are given these five values, then how can we design a non-alluvial channel? So basically, we want to know, this is a question that what do we mean by the design? Basically, the design is aimed at determining the depth of the channel and breadth of the channel. So we basically want to determine the bottom width of the channel and depth of the channel. This will complete our design if these factors are given here: Q, V, N, S, and M. So simply what are the steps which we will follow to design in design one if these five values are given. So our first step will be to find out the area of flow or area of the channel, that as we know that Q and V are given, so by using the equation of continuity, so simply we will use the equation of continuity to determine the, because continuity equation is equal is A into V. So we want to determine the A. So we will divide V on both sides. This V will be cancelled. So A is equal to Q divided by V. The second step, both Q and V are given, so we will get an evident value or clear value of A. So the next step will be determining hydraulic radius. So how can we determine hydraulic radius? It will be like this one. R is equal to V, velocity of flow. This is this velocity. N is the Manning's roughness coefficient. This is given. S is the bed slope. This is also given in the question. So we will use these three values and we will use algebraically this equation numerically, and we will get the value of R. Now we have got the value of A and R, and we can get the value of P, wetted perimeter, as hydraulic radius is equal to A by P. Here in this case we have A and R, mean we have value of A and A of R, and we want to determine the value of P. So simply we'll shift these values. R will be shifted to this and A will remain on its place. So P is equal to A over R. And the next step is to solve the equations of, because we have got A from this point and P from this point, now we have two unknowns. To keep in mind, we want to determine the D and B. We have two unknowns in this design one case. So you can say that this is case one for the design of non-alluvial channel. We have also case two. Uh, we will solve the equation of A and P to determine the value of D and B. There are two unknowns and there are two equations, so we can solve those equations to determine the value of D and B by hit and trial methods. So this is an example which is relevant to case one. We have to design an irrigation channel that is non-erodible channel. So it means that channel is not lined, because it is not mentioned here lining is provided or not. So it is non-erodible channel, mean we can consider that this is a non-alluvial channel. So first thing that we get from the data is non-alluvial channel. To carry a discharge of 15 cubics, so the discharge given is Q, that is 15 cubics or meter cube per second. When the maximum permissible velocity, as we can see here, the second indication of non-alluvial channel design, as non-alluvial channels are designed for maximum permissible velocity. So if it is not written here as non-erodible, so we can say that the channel is also non-alluvial because it is to be designed for maximum permissible velocity. So it is 8 meter, 0.8 meter per second. We will write down the data. Bed slope is given as, this is bed slope, so it is S. So we can say that this is 1 by 4,000. Mean if we move 4,000 meters in horizontal direction, we will have a vertical distance of 1 meter. And side slope is given to as m. We can call it as m, that is 1:1 equal to 1. And Manning's roughness coefficient n is equal to 0.025. So we have five values q, v, s, m, and n. So going to the last slide, we have q in the question, we have v in the question, we have n, we have s, and we have m. So we have five values. We'll follow these four steps. Last step will be somewhat lengthy, but other steps will be same, will be simple. So for step one, no, I will continue with step one. I would like to change color of the pen so we can get everything clearly. So moving to step one. What is step one? Step one is to determine the area. That is A equal to Q by V. And here Q is 15 and V is 0.8. So what will be area here? Area will be equal to 18.75 meter square. So what is the step 2? Step 2 is to determine the hydraulic radius from the formula. So R is equal to V into N S raised to power 1 by 2 and whole raised to power 3 by 2, or you can write it as 1.5. So we will simply put the values of V and S in this formula, like what is V? That is 0.8, value of N is 0.025, and value of S is 1 by 4,000. You can write the square root in case of in spite of 1 by 2, and you will write the power as 1.5 because 3 by 2 is 1.5. When you will calculate this value of R, it will be equal to 1.42 meters. Hydraulic radius, the unit of hydraulic radius is in length because it is A by P. So area has a unit of square meters and length, perimeter has a unit of uh, meter, simple length. So it will be unit of R will be in meters. So what is step 3? So step 3 is basically to determine the P wetted perimeter, that is equal to A divided by R. What is A in this case? That is 18.75 meter square. And what is R in this case? 1.42 meters. This meter will be cancelled with square and the wetted perimeter will be equal to 13.2 meters. So we have got various things here. The area is found to be 18.75 meters square and perimeter is equal to 13.2. So as we have studied in the basics, in the concepts, you can see in the introduction that the shape of the channel for non-alluvial channel is generally trapezoidal. So we can simply say that we'll consider this channel as trapezoidal and we will write the formula. So we'll follow the step number 4. It is to write the formula for perimeter and area. The perimeter of a trapezoidal channel is P plus, sorry, this is not P, this is B. The breadth of the channel plus D, or simply you can see 2D into square root of 1 plus m square. And area is written as B plus MD into D. Here B is the base width of the channel. If we are going to draw the channel like this is a trapezoidal channel. So this will be B, bottom width, and this is the, let us suppose water is flowing till this depth, so it will be like this one, D. This is D. So we want to determine these two things because we know everything else other than this B and D. So we will put the value of known things in these two formulae. This is equation number 1 and this is equation number 2. So determine what is value of P we have obtained. We have obtained value of P as 13.2. So we will write as 13.2 equal to, we have to find out the value of B, 2 into D is also unknown, 1 plus what is value of M, that is 1. And if we solve this one, we will get the equation as 13.2 is equal to B plus 2.82 into D. This is equation number 3. Now solve the equation for area. So we have also a value of area available with us. What is the value of area here? That is 18.75. 18.75. B is unknown. M here is 1. D is also unknown. This is D. And if we write it as 18.75 is equal to B D, we multiply this B with both of these values plus D square. This equation is known as equation number 4. Simply, what will we do? We will get a value of B from here by rearranging this. So simply we can write 13.2, sorry, minus this plus value will be shifted 2.82D equal to B, and this B value will be adjusted here, and we will solve for a value of D. We will get two values of D here because there is a square. You can solve directly in your computer calculator. So this equation will be like this one, 18.75 into value of B is found to be this one. This. The value of B is 13.2 minus 2.82D into D plus D square. So simply solve this one, 18.7y, and this is algebra, simple algebra. You have to manage or rearrange the equations for your interest, for your method of interest. This will be 2.82d square plus d square, and we will, when we will rearrange this equation, this will be like this one, 1.82d square minus 13.2d plus 18.75 equal to 0. So when you solve this equation in calculator, you will get two values of D. But we have, in design we only get one value. So in this we get a value of D as 1.95 meters, and other value will be something, say that will be 0.42 or something, but that value is not okay, because if we put this value of D in this equation for determination of B, it will give a negative answer. Sorry, that will be 4 point something. Let us say 4.5 meters. So if we put this value of B, D here in this equation, so the value of B will be negative. So B and D are lengths, so they can never be negative. So we will put this value of D 1.95 meter in this equation. B equals 13.2 minus 2.82 into 1.95 meters. So the B answer of B will be finally as 7.69, or simply it will be something 7.7 meters. So we can say that our design is okay, and the value of D is 1.95. So simply you can say that D is equal to 2 meters and breadth of the channel is equal to 7.7 meters. So our design is complete. because we are intended, or our main purpose was to design the channel to determine these both values b and d. So in every step we will be interested in d and b for every design procedure. So for the channel design of non-alluvial canals, we have a case 2. Uh, for case 2, there is a little bit difference in the given data. In this case, we will be given with discharge V, N, Manning's coefficient. Uh, in last case, we had S, but in this case, he has given us B by D ratio, the ratio between breadth of the channel, bottom width of the channel, and depth of flow and side slope. So other four things are same, but here only he has replaced S with B by D. So there will be a minute change, but this will be a simple, and this will be a easier question as compared to last case. So here you can see that same in step 1 we will determine the area of flow. For second step we will solve. This is somewhat different because in that case we had to determine the hydraulic radius because S was given. Here in this case S is not given, so simply we will not use the second step as the hydraulic radius, but you will use the equation of wetted perimeter. And in next step you will determine the hydraulic radius. Now hydraulic radius is shifted from step 2 to step 3, and they are interchanged. And for last step you will determine the bed slope because we have bed slope is missing in the question. So we have three things to calculate. The first thing is breadth, next is the depth, and last thing is the bed slope of the channel because it is not given in this question. So if we move towards the example, so here we can see that an earthen canal has to irrigate 24,000 hectares of rabi crop. This rabi crop, it means that we have an area of irrigatable irrigation land that is 24,000 hectares. And if duty at the head of the channel is 400 hectares per cubic, duty is denoted by D, and this is 400 hectares per cubic. Mean unit discharge of water can irrigate 400 hectares of land. So we have to determine the dimensions, means we have to find the B, D, and next thing is the bed slope of the channel, that is mandatory. So we have three things to determine in this question: B, D, and S of the canals by Manning's formula. So he has restricted us to use the Manning's equation. Assume here the B by D ratio is given. So we will write it as B by D equal to 6. Manning's roughness coefficient N is given as 0.025. And if your Manning's coefficient is not given in question, you will take it as 0.016 always. Now it is given in the question, so we will use this value. The side slope is given as 1.5 ratio 1, so it is simply 1.5. And permissible velocity of 0.8 meter per second, that is V 0.8 meters per second. So we have also five values in this case, but here we have a little bit of turnaround. So by this given data, we can proceed with the steps. So what was the first step? That is same, to determine the area. But for area calculation, we will need Q. Here we don't have Q, so I will like to calculate Q by given duty and area of, this is not area of the channel, this is area of the land that can be irrigated by this duty of channel. So simply we can determine the Q by using this formula. Q is equal to area by duty, and area here is 24,000 hectares, and duty here is 400 hectares per meter cube per second. So hectare will be cancelled, and if we get this as Q, and Q will be equal to 60 meter cube per second. Now we can move with the step 1. So what will be step 1 here? Step 1 will be the calculation of area of channel. So keep in mind, this is not the area of channel. This is area of the land that is to be irrigated by that channel. This is not the area of the channel. And a channel cannot have a too much larger area. This is in hectare. This 1 hectare is equal to 10,000 meters square. So simply, this is the area of the land that can be irrigated. So area is equal to Q divided by velocity. Q is 60 and velocity is 0.8. So simply area of the channel or area of the flow will be equal to 75 meters square. So what is the second step? In first step, we have determined the area, and in the second step, we will use the formula for the area. So in continuation of this one, we can use the formula of area. So what is the formula of area? That is for our trapezoidal channel, because this is non-alluvial channel. So we'll use the trapezoidal formula for the trapezoidal channel, that is B plus MD into D. So area is 75. We have unknown value of B. We have value of M as 1.5 from this point, and D is unknown, and D is also, these there are two D's. So we can write it as 75 equal to B plus 1.5D into D. So we have to move on a little side of from this point. So we can see here B by D equal to 6. We can also write it as B equals 6D. So simply, if this D is multiplied by on this side, so simply we can put a value of 6D in place of B. So in this formula, we will write 6D in place of B. This will be 1.5D into D. So it will be 75 7.5D square. When we solve this, we will get two values same like in last question. So we will have two values, but we will adopt the value of D, which will give the positive value of B. So simply D will be equal to 3.16 meters. And value of B corresponding to this value means simply the value of B is 6 times the D. So we will multiply this 3.16 by 6 and it will be equal to 18.96 meters. This is value of B. We have designed the channel, but now we have to determine the value of S. For S, we have to calculate P. What is P? That is B plus 2D into 1 plus M square. So what will be perimeter here? B is 18.96 plus 2 into D is, what is the value of D? That is 3.16, this one, and 1 plus M is 1.5 here, 1 plus M square. If we calculate the value of P, it will be equal to 30.37 meters. So we have value of P, we have value of A. Now we will determine the value of R, hydraulic radius. So what will be value of R? Simply R is equal to A by P. A is 75 and P is 30.37. So our hydraulic radius will be equal to 2.47 meters. So we have a formula, that is Manning's equation, n r raised to power 2 by 3 and s raised to power 1 by 2. We have to determine this s. So simply we will rearrange the equation and it will be equal to v n r raised to power 2 by 3 and whole square. This is formula for s. We will put the values here as 0.8 the value of v, 0.025 the value of n, and value of r is 2.47 raised to power 2 by 3 and the whole power has 2 means square. So if we solve this equation, we get a value of s in fractions, but we will write the value in s by d units, mean in fractions, ratio, means it will be in 1 over 8347, means if we move 8347 meter horizontally, then we will get a distance of 1 meter vertically. Mean bed slope of the channel is adjusted in this way. 8347 meters in horizontal direction, we will have 1 meter of vertical downfall in the channel slope. So this is all about the design of non-alluvial channel. In next video lecture, we will discuss the design of lined channels, and in further video, I will discuss the design of alluvial channels as well. Thank you very much. If you like my videos, subscribe my channel. See you in the next video. Take care. Allah Hafiz.